All right, we'll go ahead and get started. So, pretty exciting event, live event that we have going on today. So you have myself, Tim Williams, Vice President of Sales here at Batesville Products, and
Rachel Weber, Regional Sales Associate.
so what to me, what's a little bit exciting today is not only the topic we're talking about, but we also are live on YouTube for the first time. So we have quite a YouTube. What I would say is a library of videos, short clips, a lot of educational tools and tips that we've shared over the years, and different content that we've made from that perspective. But um, have a large following from that educational side of things. So wanting to get out to that subscriber base and sharing some of the information live to that group as well. So excited to do that. But again, with the interesting topic we have to share today, as I just mentioned, if you have any questions, feel free to drop them in the webinar chat here. What we'll try to do is, if they are specific to a slide that we're on, we'll try to answer them to that slide, and then we'll try to recap anything at the end if there's still questions that are left out there. Additionally, if questions go unanswered, we'll be reaching out to you more specifically to see if there's something we can help answer. Additionally, anything that is recorded today will be emailed out along with the slide deck. So if you are unable to attend and are attending at a later time, you'll be able to get all the information. And again, reach out to Batesville Products with any questions here. So with that, Rachel, why don't you tell us a little bit about yourself?
I've been with BPI for a little over 4 years now. When I'm not at Batesville Products, I enjoy being outdoors, doing some crazy sports. So that's me.
Crazy as in marathons and triathlons and half marathons and
Yes.
ultra marathons. Not yet.
What about you, Tim?
Yep. So Tim Williams, I'm a Vice President of Sales here at Batesville Products. I've been here, I believe, a little bit over 12 years now. Been in a bunch of different avenues of Batesville Products. Started at purchasing, but have been in sales now. I think reaching 9 or 10 years now. In my free time as well, I got three little ones who definitely keep us busy. I'm coaching my son's basketball team right now, and if you hopped on earlier, you heard Rachel and I kind of talking about that same kiddo wanting to start his own YouTube channel. So just managing through the kids right now, but love to spend a lot of time with the family. With that being said, let's go ahead and jump in. Again, today we're going to go over the some 8 common mistakes that we come across. That we, not only from Batesville Products perspective, but a lot of what we hear in conversations among the industry, some of our networks and roundtables that we talk with. But with the first one, let's go ahead and hop in. So using the wrong material. So what does that mean to you, Rachel? What do you come across and what do you see?
So I believe this isn't really necessarily something as a salesperson I can say you're using the wrong material. It's definitely a engineering side where you just have to do your research on the product you're utilizing.
Sure.
But understanding what's important about the metal and your end use so you know what you're getting out of your product. So just I think choosing the metal will also choose your process that you're going to manufacture with.
Sure.
So if you're looking for something lightweight but durable, aluminum is a great way to go. So we cast A356 in ZA12 and ZA5 at our facility. You can see those in the blue on the screen, and you can see how they compare to some of the other main materials used in the industry.
Sure. Yeah, I think like you mentioned, I mean, we're not engineers, and by no means are we metallurgists. But obviously, when you're designing a product, material is going to be important. And whether it's the durability of the actual material, whether it's while we're saying it sounds funny, but while it's the flexibility on machining, the durability, for the life of the product, whether you have corrosion areas, whether you need weight, whether you need to remove weight, really, a lot of factors there. And I think, and we talk a little bit about it on the next slide, so I won't get too far in front of it, but oftentimes it matters what type of process you're using as well, because what we come across, A356 can be comparable to like a A319, A380, depending on what type of casting process you're using, and have similar properties. But you don't want to limit yourself and say, hey, I only need A380 when it could fit in those other
Yeah.
categories, and it's not really removing the properties that you would still need as an end result of the casting. So different things like that. Obviously, end applications as well. So again, if you're going in food equipment, or if you're going underneath the bed of a truck, or depending on where your product's going, and the durability of the casting is very important as well. So mentioned a little bit, but some of those metals can definitely differ based on the type of process you're using. But making sure you're using the right process is very important. So a lot of times, what we hear and see, in the industry, it's dependent on a lot of the surface finish, the amount of quantities that you're running, thickness and thinness of walls, whether you can open up draft, not have draft at all. Really what you're trying to design and how it fits into what process. So on the screen, there's a lot of details. We won't go into too much. We won't read through each individual one, but really quick snapshot of a table that really helps you explain that. And some of those are generic. High could be completely different, for volume to BPI than it could be for a die caster. So really making sure with your partner, you're breaking it down and saying, hey, what really does make sense here? Is this fit for your process? And a lot of times a good caster or a good vendor in that perspective really spells it out up front and really helps you understand and shows you the right way to be going there.
Yeah. And I would say too, if you're looking at quantities as a reason to choose one process over the other, a lot of times you say sand or investment are good entry level tooling cost for getting into castings. And the only thing you just have to consider when you pick those processes is what your end production process is going to look like. Is it going to be die or permanent mold? Because there are different tolerances that you are going to have to consider when you are getting started that you may have to adjust when you switch processes. So if you're doing investment casting, it's a little bit easier to switch to die casting because it's got the closer tolerances you need. Whereas sand might be a little bit more conducive to permanent mold, switching to those.
Sure. Yeah, I think something to think about here too. So specifically with like a die casting or a permanent mold, a lot of it looks at there's similar type molds where you're using reusable steel, but with permanent mold, you're trying to eject, and we're not force feeding metal like in a die casting. So you need to have drafts or tolerances that allow you to eject that part. So you're ejecting metal from metal, right? And same with the feed. We need to be able to use, the feed pass to get into the actual casting and solidify and not have the shrinker porosity that you could see if it wasn't designed correctly. So a lot of different things to think about. A really important one that I see from the chart as well on the far right there is the RMS finish. Again, if you're putting a product that's hidden somewhere, maybe on the underside of a truck or high up on a lamppost, is a 20 RMS surface finish in a die casting, is that something you need? Because there's a cost associated with that. If you're doing something on a piece of, nice sleek piece of food equipment that, Rachel's going into a shop and using, you may want that to have a higher surface finish. So that RMS really gives you a ballpark of where those ranges start. There are obviously post-processing opportunities. A lot of times what we see on different food or medical equipment that we do, we're able to post-process that in our polishing departments on site to get it to a better surface finish, or if it's 200 is good, or if it comes off on ABC surfaces and 120 is good there. There's ways to get to the end goal in mind.
Yeah. Before we move on, the other thing to consider, it's kind of tying back into the previous slide, is with die casting and permanent mold, you're going to be limited a little bit to the types of metals you can cast into it, whereas you're going to have a wider range of materials you can use with investment in sand.
Yep, absolutely.
Not designing
Hey, Tim
for...
and Rachel, before you keep going, we got a good question here from Michael. He says, how much does the specific casting process affect the material properties, like gravity pour versus other processes? I know you touched on this a little bit, but can you go a little deeper into that?
Yeah, absolutely. It ultimately depends on what your metal is, right? So if we're using A356, That's a metal that can be used in both sand and permanent mold. It's comparable to A380 in a die casting. They have similar properties. There are some slight differences, but for the most part, it's not really changing the mechanical properties too much to the positive or negative on either one, right? The A380 is very similar. If that individual, I didn't catch the name there, Mary, but if that individual, we can reach out specifically and send kind of a high level material type cert to explain that a little bit better. But for the most part, mechanical properties don't differ depending on process.
Yeah, I would say that really that what difference in process it would be the level of gas that you're going to see in your part or porosity, however you want to word it, is kind of where you're going to see the difference when it comes to the metal through the processes.
Yep, and again, a high level die casting, you're forcing metal in, permanent mold, you're using gravity fed. Investment, you get kind of best of both worlds. You're getting that sleek mold, but you're still kind of, you're using a little bit of the gravity still, but you're getting the sleek walls and tight tolerances that you can get from a die casting. And then sand, there's like a V process in sand that allows you to do some more of the vacuum or the pressure. But sand specifically is more of it's not a gravity tilt, but more of a gravity flow type process as well.
So jumping back forward, so not designing for casting. So some of the biggest things we see is just making sure that you understand the process that you're casting in. So for example, die casting and investment casting, the draft, we'll start with the first one, draft requirements are much more lenient than they are for permanent mold and sand casting. That's just due to the size of the nature of the part. So you're going to have less draw to begin with. So you don't, and the pressure of the part. So you're going to be ejecting it out much differently. So you're not going to need as much draft to be able to pull the part out of the specific mold.
Yep, that's a good one. I mean, think of just cutting like a cube, right? You cut a cube and you have your vertical walls and your horizontal base and top. Think of trying to pull that cube. It's almost like your little play set as a kid, right? You're trying to put that cube in that cube hole. Try to pull that out if it's as tight as possible. You're trying to get that out of there, right?
It's have that suction.
It's hard. It's going to rip it. If it's got paint on it, it's going to pull the paint off. So that's an easy way to kind of think of the draft side of things. If you got metal on metal, you're trying to get this metal out of the mold. So really, no matter what process you're doing, you're going to need some kind of draft, right?
Yeah. Well, and then you look at thickness, which is the wall thickness, the next section. That one actually really is important across all processes because you're going to have to fill the part out somehow. And whether it's gravity or pressure, if you have a wall thinner than the rest, you're going to have freeze off. So it's not going to be able to fill as efficiently, whether it's pressure or gravity kind of going into that cavity.
Yeah, that was going to be my question to you. What does a freeze off mean? And then that's a good point. We need to make sure, no matter the processes Rachel had mentioned, that you're filling out the casting. So if you have thin or thick sections in your product, some of those may need design changes depending on what you're looking at to make sure your casting is actually castable, right? So you can actually get a good casting out of it.
Yeah. Last one, fillet. So this one is really more so when you're ejecting the part out, it's gonna nick and rip, or you're not gonna get a nice, clean, sharp edge like you want. It's going to, no matter what, something is gonna break off on it. Even with machining, you can't always get a nice, clean edge like you want. So you always have to have some sort of fillet or radii afterwards added so that you can make it easier casting to manage.
Yeah. I'd say in general, so we talked about some of the processes, the different types of casting process in that previous slide. There's different benefits, different types of wall thicknesses, different types of drafts, different types of expectations from fillets that are required. Again, if there's specific questions to those, we'd be happy to answer them. And we do have a really good guide online that, again, gives a high level of information on the different types of processes and where you kind of start when you're doing your design process and your design expectations for your end needs there. So we're checking out, but always open to sharing that with the group here as well if that is requested. This is a cool one. And I would say from my experience, and again, being in the industry for a little over 12 years now, you don't see this all the time, but we do it all the time. So really what we're trying to do here, and what you see on the screen is an example of a simulation. We're trying to solve out issues that are seen digitally before we cast a product. So the reason being, and is if you remember back to the number 2, where we talk about the different types of processes and expenses from a tool perspective, we want to cut a good tool before and design a good tool before we even start to try casting. And the reason being is you can't make a good casting further down the line in your machine shop or at the coating department. You have to do it at the casting operation, right? So going through this process, there's a lot of different things a simulation can tell you. And you can look at it again, both from a casting perspective and the gating and the risers and everything from that perspective. You could also look at it from the mold perspective. So it really helps you design out a successful process and product and how you're going to do it prior to even cutting or attempting to sample the part once getting the molds in house.
And I would say this is actually becoming an industry standard amongst other industries as well in manufacturing, not just metal casting.
Yep.
So I think it's a practice a lot of, even if it's like plastic injection molding.
Sure.
A lot of people are using this method, and it's just a really good way to fine tune your part before you get it into production, just so you have ease of startup on a new project, and also so that you could see the potential risks that you're going into with the process that you have.
Absolutely. From my perspective, I think they're cool.
Yeah.
They give you essentially a real life simulation of what it's going to end up looking like. And really, again, helps our engineers go through the process of, okay, that left one there, you see some red area. How do we solve out where that may be trapping off metal or not staying hot or cold enough? How do they solve? And I think on that one, it's full. Let's see. I don't think we specifically. So there's different things it looks at from shrink, from hot areas, cold areas. If there's cutoffs like Rachel was mentioning earlier, if you're going to shrink or porosity just from the casting method, that red area could bring to light an issue that can be solved before they even cut the mold.
Yeah. So you touched on this earlier about surface finishes and talking about ABC finishes. So not clarifying your surface finishes can either increase your cost of your part and or potentially cause a supplier not to quote it just due to high tolerances that are not necessary. So really anything that's going to be exposed that is going to be customer facing usually is what we consider an A surface, depending upon the application, of course.
Sure.
So if something's being exposed to a customer, but then is going straight into a manufacturing industry, for example, like it's going to be out in the weather, then maybe it's not as big of a deal. But for example, this is a medical piece of equipment, so this one's going to be seen every day. You're not going to want to show off poor surface finish on this, but you're also not going to see the underside. So that's where you can also have a little bit, and there's also, if you see it, it's not going to be as easy to get a good surface finish there with a polish. So just making sure you kind of clarify what your surfaces are going to be seen, and then that will help your engineers or your foundry to develop a part that is more cost efficient and also more manufacturable friendly.
Yeah, so Rachel hit on a really good point with the product specifically on the screen. So this is a really cool application. Again, it ends up in a medical space there. This customer was really on top of it, really understood, hey, this is our A surface from the whole area, even on the left and right end there, all the way to where it meets up with those 2 bars. It's still an A surface area, but on the internal cavity of that, it's not, right? And on the underside, it's not. But on the underside, that's where they made up with the rest of the unit. So it's got critical components on the inside, some of which are machined, some are not, some are cast. But really understanding and working with that client, and when you're designing, to understand what are your expectations. Is this going to be seen in public, 5 feet from a person, or is it going to be 500 feet up in the air? Is it going to be touched, or is it going to be, a mile in the distance, right? What actually matters? Is surface finish actually a quality or component that's needed for the end product?
Yep.
So category I can put this in is over designing, right? Yeah. Sometimes we get, there's products out there that they're like, oh, this is an A surface, but understanding what that means on our RMS surface finish.
Yeah.
In the same breath, we know clients want to sell a product to their customers as well, that they want to look great, but sometimes the surface finish doesn't end up mattering at all, right?
Yeah.
Right. So similar to kind of the surface finish area, there's other processes or operations that could be looked at to add or remove some of the previous stuff that we had talked about, like the fillets, or if you need a 3 to 5 degree draft, but you can't live with that in your end application, do we machine it? Does it need hollow cavities? Does it need added or removed strength? A lot of different applications, and again, end goal of mine of where that product goes, really understanding that. And then, the question earlier about the different material types. Hey, there's heat treatment processes that can help benefit, from a strength and mechanical property perspective. But there's other opportunities here as well.
Yeah. And there's on here, we listed sand, core, and shakeout. Those are some things that your foundry, if you're coming to them with the product and you say, hey, cast this complete for me, they'll make sure that a sand core is needed and the removal of it is needed as well. So that's one thing that your foundry should be telling you if it's going to be a requirement or not. And then machining really too, if you've got a complex casting that can't be fully completed with the way it's designed, and your foundry should be able to say, hey, we're going to need some secondary machining to get to this end product.
Yep.
And then they'll ask you if that's something you want to quote or not, or if that's something you're willing to do yourself.
Yeah, and again, the machining world has some of the limitations as well.
Yep.
But obviously, the goal from the casting is, in die casting and permanent mold and sand casting, really, the reason you go casting is it doesn't make sense to machine it out of stock anymore. Your quantities get too high. You need different tolerances. The cost savings from a casting versus a machine component. Really, what you're trying to do is get a near net shape coming off of the casting process, so that your machining is minimal, but you're machining the critical areas of need, right? As Rachel mentioned, sand cores are kind of unique for the permanent mold process. They're used in different processes as well, but essentially it's to hollow out cavities that you can't do from a steel core or steel mold. So more of a specific process or specific need, but it is an opportunity. And then, again, if you're doing kind of an as-cast surface finish, but then you put a textured application of the coating on it, that may, eliminate a lot of the polishing that's needed in between and really get you to an end product there. So again, understanding the design and then the end in mind of where that product goes and how you want it to look. So this is
I think this is the key.
Yeah.
Key one.
Yep, absolutely. So I think throughout the entire process, obviously communicating as much as possible from the start.
Yep.
There's reasons you reach out to vendor X, Y, Z, right? So making sure that those vendors understand, hey, this is a new product. This is an existing product. We have these issues. If it is existing, we're running into these issues, even if it's a new product,
Yep.
right? Because casting houses and facilities will have expertise to be able to help you down the path that you need to go.
Yep.
But they can't help you if you don't know what if they don't know what they don't know, they can't help you, right?
Yeah, it's definitely one sometimes I think even foundries, they also need to start asking the right questions too and digging to understand, because if someone's coming to them, they're not too familiar with casting, they're not
Sure.
going to know what expectations to communicate. So in turn, it's also on us, the foundry experts, to be kind of inquisitive and asking the right questions to understand, is this product the right fit for this type of process?
Absolutely, because I think that cross communication, and it's on that first line there. We know our capabilities very well. We know castings very well. We don't know your end product design really well. We look at the drawings, the models, the prints. We high level from explanations, understand where you're going with it, what you're designing. But we don't know your customers, right? We don't know your staff. We don't know the capabilities that you have in house. So really, that cross communication from both sides and being honest with one another, and each other, to really understand how can we help you get to your end result there. Some of that comes with specifications. Some of that comes with again and end application, where you're putting it. Oftentimes depending on the other administrative industries that you deal with, FDA or anything from that perspective, there's requirements that you may not need on your product, but you need because you're involved in that, right?
Yeah.
So really understanding, hey, let's not overkill anything, but let's do things right. So the last one here is pretty hot topic right now with the new administration. A lot that's going on internationally as well, but avoiding domestic manufacturing is kind of a hot topic right now.
Yeah. This was kind of an interesting one too, because recently had a conversation with a customer of ours who had dealt with overseas manufacturing. And one of the things too you forget is that the minute something goes wrong, you're all of a sudden having to scramble to figure out how to get good parts in, and then you're potentially having to air freight some very heavy castings over if all of a sudden you receive a truckload or shipment load of bad castings, and then you have to scramble to get new ones and then just pay essentially all of that scrap with air freight.
Absolutely. Yeah. Another story that I had heard this year, actually, 2024, had a client that was taking 2 weeks to ship to the shoreline. Then they had to sit on a ship for 4 to 8 weeks, depending on what it did in the port. And because of the amount of product that they would use annually, they'd buy their annual lot, get it in, and they're paying for a whole container, and all of a sudden the whole container's bad. Well, what do? You just got all your product for the year, and now you can't use any of it. You try to rework as much as you can. You spend more cost on that. Can't really ship it back. I mean, there's a lot of unseen challenges to that. But there's also, the other side that, hey, we understand that labor in the United States is cheaper than other areas in the world, right? It's understanding what value are you looking for in your castings, and what's the end application, and what can you, what can you really look for when you're looking for that type of casting.
Yep. And I think it's kind of goes across the board too, wherever you are located. Just sourcing domestically and locally does reduce kind of that unsureness of where your product's coming from. So you can go visit the facility if something is going wrong, and you can see the mold that you're using on your part. And it's much easier to kind of knock on the door if you're not hearing anything than it is if you're a couple oceans away.
Yeah, absolutely. I think to Rachel's point on that previous slide with the communication, I mean, Rachel, myself, Batesville Products can be on your doorstep within, the same day to discuss any types of problems or issues. We can discuss the communication on a product kickoff. Hey, this is where it goes. I want to show you. Look, this is what it looks like. Really build up that confidence, that conversation back and forth to understand, hey, good casting. Here's how we plan on doing it. Make sure we're not overkilling it, right? We're not doing stuff or looking at surface finishes that we don't need to be looking at. It's an extra level of service, I guess would be the word, that we can provide, that there are challenges with to non-domestic sources. So definitely both benefits both ways, but again, with the hot topic and a lot of the the government and the new administration as it is now, I think it's going to continue to be a hot topic. So always worth, again, on number 7, going back to your communication of communicating with your supplier of choice or maybe your future supplier of choice.
Yep.
So with that, I had mentioned early on when we had started, there are a number of resources from a video perspective on our YouTube channel, a lot of shorts. So if you don't want to watch a whole webinar, a whole education series, there are a lot of shorts explaining different things, different topics. As well, our website has an abundance of information as well. One of the specifics that I had mentioned earlier is that design guide. Again, it gives you a high level of some of the more common casting processes, such as die casting, sand casting, permanent mold, number of the different processes, some of the technical side of things to look for, from draft, fillets, radiuses, things of that nature, to really make sure that you're designing a solid casting from the get-go. But hey, as always, any questions, feel free to reach out to us. Appreciate everyone attending today. So we had somebody from Denmark join, so that's exciting.
Yep.
But as always, any questions, feel free to let us know. This recording and webinar will be sent out. And last thing I wanted to share before we talk further was there's a potential for an open house coming up. So if you're interested to see Batesville Products, what we do, meet our team, walk through the facility, keep this on your calendar. There may be some stuff going out here in the near future.